can't really go on any adventures for real right now. So we're just going to look at pictures of people going on adventures. So I'm just going to talk through really quick the schedule for the day. Just like I always do, I'm going to make it pretty quick for you guys. If you're here today, you have no extra assignment. There will be a Schoology quiz posted in our folder. It'll show up as a due date. You do not have to do it. So being here is all you have to do for the day, and that's your assignment. So when you see that Schoology quiz, don't worry about doing it. You don't have to. So we already checked in, talked about our go-to snacks. I have a couple updates for you, a couple of reminders for you, and then I want to quickly go through kind of what we've learned, some of the big ideas from the last few days. I'm going to send you guys into breakout rooms. I don't know if you have used those yet or not, just to kind of talk through with some of the people in the class the things that you've been writing down and that you've learned about sickle cell anemia and how the things we've been doing apply to sickle cell anemia over the last few days. We only have 2 topics left to get our full explanation of sickle cell anemia. They are mutations and then natural selection. So we're almost done. We're almost ready to come up with that explanation. I'm just going to give you a quick little mini lesson on mutations. That's going to be what you're doing tomorrow. And then Tuesday, Wednesday of next week, that's when you guys are going to be doing natural selection stuff. I'm thinking about maybe doing a lab on Zoom and maybe like collecting data. We'll see. I'll talk to you guys about that in just a minute. So updates. Everybody should have seen this, and I hope you're happy about this. We do not have a final exam anymore. It's canceled. I'm really happy about that because I think it takes a lot of pressure off of everyone to study and get a bunch of stuff done and cram in a bunch of material we weren't going to get to. So I'm really happy about that. So kind of keep that in mind. We have 1 assessment score left, and that assessment grade is what we're doing right now. Okay. Another reminder, Monday classes, you don't have them anymore, but Mondays are still a work day. So when you're thinking about due dates and deadlines for your assignments, that still counts as one of the days you have to work. Now, one thing I realized, I've been doing my due dates wrong. I've been assigning things on a Wednesday and making them Wednesday. It should be, if I assign something Wednesday, it's due on Tuesday. So I have to kind of go back and make sure that all of my due dates are updated in Schoology from this week, like moving forward. But kind of keep that in mind as you're completing things. It's not Wednesday to Wednesday, it's Wednesday to Tuesday, Thursday to Wednesday. That's your 5-day window. So that's my fault, and I did want to let you guys know that. Okay, so a couple of reminders. Sorry, just let this person in really quick. Okay, a couple of reminders. We only have 1 assessment left. Every single piece of our explanation is related to something that we're doing in class right now. So when you're doing something on transcription and translation, I want to make sure you guys are thinking about how does this relate to sickle cell anemia. And we're going back to that idea of our normal hemoglobin and red blood cells versus our mutated hemoglobin and our sickle-shaped red blood cells, okay? So I did see you guys kind of turning in your what I've learned, and some of them were great and really specific. Some of them needed some information added to them. That way when you go to do your assessment, all you have to do is pull the information from that list, and you don't have to do too much additional explaining. So the goal is to kind of get you guys building it piece by piece, so that you don't have to do a bunch of work at the end to get that explanation done. Okay, it should be a very specific explanation that's combining all of those pieces. Okay, now in addition to that kind of assessment reminder, remember your Harper grades are the grades you get in this class. So there are people who are borderline. I know I've talked to you guys. I can make this last assessment a really big chunk of your grade. I'm doing this to help you guys, but one thing I've noticed is a lot of people are kind of falling off and not doing their work. Right now, this is the time to raise your grade. A lot of you guys needed this opportunity to get it up. I know seniors, you're like, I only have a few days left, but try to keep yourself motivated to get that grade up, because unlike a lot of your other high school grades, this grade's following you to college next year. So you're gonna have this grade for 4 more years of your life. or if you're a junior, 5 more years of your life. So this grade is going to follow you. Last day for seniors is coming up. Our last day with you guys is going to be the 13th. So juniors, you really aren't going to have a lot of assignments after those seniors assignments. But one thing I wanted to know, like, I want to do something fun for you guys. We're not going to be in class. I don't know what to do. Do you guys have any ideas?
No.
You have no ideas?
Like, I don't know what we could do. Like, when we're online, that's the thing.
Yeah.
You know what I mean? It's just, like, kind of hard.
I totally get it. I totally get it. If I did something like class awards and you all came up with like an award you would give to someone in the class, like a goofy award, and made a Google sheet, would you guys want to do something like that and then like present them at our last Zoom day?
Like the Dundies or something?
Yeah, something like that, like whitest sneakers, or, you know, like just like you guys could come up with some categories, and then we could vote on them and we could like give awards that last day. Would that be something you would want to do?
Sure.
Yeah, would you?
Sure.
Yeah, that's
If you-
fun.
Okay, just something fun, like to say goodbye. I know our attendance is low today. Hopefully it'll be better, but tell your friends like to come to our Zooms. They're helpful. Okay, so I will try to get something like that together. That will probably be an assignment for you guys then one day, is to just like come up with like a few different categories of awards, and then another assignment day would be to vote. So remember, our last real assignment, it's gonna be on the 6th. So we'll just do like a bunch of like little fun assignments, little things for class, for those last few days. Okay, so that's kind of the plan there. Okay, so moving on to kind of what we've learned about sickle cell. Since we met, we've talked about protein structure, the structure of DNA and RNA, and then transcription and translation, which make up gene expression. Now, when you guys are filling out that what I've learned or what we've learned about sickle cell, I want you guys to kind of be thinking about these questions. So when you're thinking of protein structure, what determines the way a protein folds? What has changed in our hemoglobin that makes it fold a different way in our normal hemoglobin versus our mutated hemoglobin? DNA and RNA, what is it about the structure of those molecules that allow it to actually store and transmit the instructions for making a protein? What kinds of things can change that would make that protein different? Transcription, just talking about, okay, well, how do we get our message from our DNA outside of the nucleus to where we can make a protein? And then translation is more of just an explanation of how are we actually putting that protein together. So I'm going to kind of go through one example with you very quickly of what you should kind of be doing when you're filling out that model tracker. So this is what your tracker looked like. You've got this what I've learned. And so far, we've really just filled out this first page. What we're working on this week and what I'll probably have you do as part of your assignment tomorrow is fill out these next couple of boxes. So you can talk about this one today. Gene expression is transcription and translation. Just kind of getting some specific ideas of how this all relates back to sickle cell anemia. So for example, last week we talked about protein structure. In this box, I would want you, I'm not going to type it all out, but I would want you to include information about the 4 levels of protein structure, okay? And for each level, I would want you to write down the types of bonds that cause the level of structure. So for example, in your primary structure, it's those peptide bonds that connect the amino acids, okay? And for example, our tertiary structure, which is the actual folding to get the functional protein, it is a bunch of different types of bonds, so many types of bonds that occur between the R groups. Causing the, oops, can't spell. the primary structure to fold in on itself. Now, if we're thinking about how protein structure and protein folding leads to sickle cell anemia, we would also want to include a little bit more information. We might want to include something like a single change in the amino acid sequence of a protein can lead to an altered structure. Not always, but it can lead to an altered structure. So that might be something that relates back to hemoglobin. So we might want to ask ourselves, how does a change in the amino acid sequence occur? Okay, and that would get us to kind of like our next step of thinking. So when you're filling this out, okay, make sure you're kind of getting in to that protein structure. We might also want to ask another question for ourselves, like what happens to hemoglobin structure, right? We don't know what level of structure is altered, so maybe that's something that we're going to explore later. So make sure you're kind of tracking for yourselves, like what do I know and what don't I know? And I was not super specific about that before, so I wanted to be very specific about that now, okay? So we've learned about a few more things: DNA, RNA, transcription, translation. So what I'm gonna do is I'm gonna put you guys in a couple of groups. Have you guys used the breakout rooms before?
No.
No? Okay, so I'm just gonna put you guys in a few rooms with a few other people. I think I'm gonna do 3 rooms. And I just want you guys to take a second to talk about, okay, what have I learned? What information might I want to include? Where are we going with this? Just so you guys can get some ideas, okay? So there are a couple of things we still don't know though. One of those things is, how do we end up with these 2 different versions of hemoglobin? And the way we end up with those 2 different types of hemoglobin is because we have a mutation. And a lot of times we think about a mutation as being this really, really big thing. But what a mutation actually is it's any change in the sequence of our nitrogen bases in the DNA. So let's say we had a DNA sequence, it was AATTCC, maybe it changes to AATTCG. That is enough to be a mutation. Now, mutations are actually a really good thing in some ways because they do create a lot of the variations that we see within our population. So if you think about certain things like blue eyes, at one point that was one person who had a mutation. If you think about the ability to digest the lactose in milk, that is a mutation that came about. Not everybody has that mutation, but that was a mutation at some point. So we have this tendency to think that mutations are just like this bad thing. They're not always bad. So I want to point that out first. They often are bad, but they can be beneficial, they can be harmful, they can have no effect. Okay, now where our mutations come from are a couple of places. First place would be a mistake that occurs during DNA replication. Remember that during the S phase of interphase, before we go into mitosis, that's when DNA replication happens. We have to make a copy of the DNA before our cell divides so that we can pass on the same amount of genetic material to our new cells. So that's one place. Sometimes you just make a mistake. We've got millions, actually billions of base pairs in our body. So sometimes the DNA enzymes that make it just kind of trip up. Another thing is exposure to mutagens. So you can kind of think about things like asbestos, which is a mutation causing agent. There are lots of things that cause mutations. Another one of them is sunlight. We learned about some of these things in our cancer unit. So any exposure to a mutagen or a mutating causing agent could also cause damage to your DNA that could be harmful to your cells or could not be harmful. The only mutations, though, that you can pass on to your offspring are mutations in the sex cells, so in your sperm cells and in your egg cells. Okay, so mutations in your body don't get passed on unless they're in your sperm cells or your egg cells. Now, there are 2 primary types of mutations. I'm going to talk through them really, really quickly because one of the things that you're going to do tomorrow is you're going to determine what type of mutation actually causes sickle cell anemia by looking at the DNA sequence and then transcribing and translating that DNA sequence to form a protein. So we have two types. Our first type of mutation is a point mutation. You can also think of this as a base substitution. In a point mutation, only one base is replaced by another base, okay? Now that can lead to a couple of different outcomes. It can lead to a missense mutation, which means we have changed a single amino acid in the primary structure of our protein. Remember, that's going to lead to changes at the secondary, tertiary, and quaternary level. Okay. It could be a silent mutation where we replace that DNA nucleotide and the amino acid doesn't change. So if you guys remember looking at your codon chart, you should have seen there's a few different codons that code for a single amino acid. So maybe we switched that one base, but we ended up with the same amino acid. The third type is a nonsense mutation, and that's what would happen if we change a single amino acid and it turns into a stop codon rather than the amino acid that it was before. So a stop codon is going to cause the transcription and the translation, excuse me, of the protein so that we don't make the full protein. Now, typically a base substitution is not a terrible mutation to have in your cells. A nonsense, though, that occurs pretty early in the protein is really, really bad because you don't end up with a functional protein at all. Now, typically the worst category of mutations is going to be a frame shift mutation. Again, kind of depending on where it happens. If that nonsense happens early in the protein, that's really bad. But the frame shift mutation is a mutation that actually shifts all of the codons to the left or the right so that we're not reading it in the same groups of 3. So all of our groups of 3 codons are going to change after a frame shift mutation. So there are 2 types of frame shift mutations. You've got an insertion where you're actually inserting a new base. Okay, so instead of substituting, you're inserting. What that's going to do is it's going to shift your reading frame to the right. So you're going to have one extra nucleotide at the end of your sequence, and all of your codons are going to shift. So after that insertion, all of the amino acids that follow are actually going to be different. You can also have a deletion where instead of inserting a base, you're deleting just one base. Your whole reading frame shifts to the left. You're going to have 2 extra codons at the end, and every amino acid after that insertion or deletion, is going to be changed. So these typically, if they're happening early on in the protein, they're really, really bad because we're going to have like a protein that makes no sense for what we're trying to do. Okay. That is your mini lesson on mutations. You're going to learn a little bit more about them tomorrow, but do you guys have any questions for me now? Okay. Well, it was good to see you guys. I kept it at 35 minutes, so not too bad. I would like to see everybody next week. If you know people who should be at the Zoom but are not here, encourage them to join the next one. Okay, you guys are done with everything for the day. It was awesome to see you guys. I miss you so much. I'll think about some senior awards. Okay, bye guys.
Bye, Michelle.
Bye. Have a good one.
Bye.
Thank you. Bye guys.
Okay, I have a question.
Okay, hold on one second. I'm gonna